Okay. Awesome. 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 All right, guys. Thank you so much for joining this new week again. This is a third week of Precision Agriculture Incubation Program. I'm actually excited, really, and trust me, we've been putting a lot of preparations in place, for our practical sections, that is going to be commencing also later this week. So, thank you so much for joining in again. I would remind you to actually invite your friends and even enemies, to come join us here. Uh, so we're going to be talking about drone technology today, and I'm actually excited to have David Opateyibo with us today. Thank you so much for your willingness to share with us, David. Now, without further ado, I would be bringing up on stage Joseph to actually run us through our Precision Field Academy, what we do for those who are actually just joining us. And, so Joseph, you are welcome on stage. Yeah.
All right. Okay. Thank you very much. Good afternoon, everyone. It's really good to be here again, and we are making progress. So I'm gonna be taking us through the briefing. So welcome to Precision Field Academy. At Precision Field Academy, our vision is to create a world where every young person, regardless of their background, has the opportunity to become a digitally savvy farmer or agricultural professional, driving sustainable and equitable growth in their communities through the transformative power of technology. And our mission is to raise next gen farmers that are tech inclined and digitally savvy. So at Precision Field Academy, we are a social enterprise. We train and build the capacity of young professionals in modern and emerging technologies for the future of work and to lead with precision agriculture. At ease, we are bringing all the new narratives in the world of agriculture because agriculture must go digital. So we believe in three core methodologies. Number one, which is education and knowledge sharing. Uh, it's about facilitating professional courses and programs like this. Also, we believe in training and skill development that is hand-on technical skills that can actually warrant you to solve problem and bring up workable solutions to life. So also the third methodology is coaching and mentorship. This is expert guidance or expert-led mentorship that actually helps you to it optimize you in your career journey in terms of precision agriculture. So we also have in focus tech skills, which is not limited to drone technology. So we are leveraging drone technology to solve problem in agriculture, building the capacity of young people, solving problems for farmer, and also food security challenges. We are solving food security related challenges, leveraging on drone technology. So we also have GIS, Geographic Information System, and remote sensing. This deals with collection of data from the satellite and also using drone technology for remote sensing data collection. We have data science for agriculture. This about the algorithm of how data operates both the front end and the back end of data in relation to agriculture. So we have robotics and Internet of Things. It's much about the embedded system, where you have systems positioned on the farm, giving a response to the environment for them to operate and also make a farm efficiently. So we have artificial intelligence and machine learning. So we are in the dispensation whereby artificial intelligence is taking over. We are doing a lot of things with the help of AI, and this can actually help us in the aspect of predictive analysis to make certain corrective measures, yes, to prevent other unforeseen circumstances in farming. Lastly, we have enterprise development. The goal of all this training at Precision Field Academy is for you to be able to create a sustainable enterprise that can actually create solutions to solve global terrifying problems. And that is why we have this. So let's move forward. So what do we like? Why do we do what we do? What's our motivation? Uh, we discover there is a skill gap that really needs to be closed, and young professional needs to build skills both on the technical and enterprise skills for the future of work in agriculture. Also, observing the trend is not enough. Youth needs to become an enabler and player in the fourth agricultural revolution and not mere observer. That is, you must be involved. You really need to take charge. So, like, you shouldn't just be inspired by this technology alone. You should also come up with solutions, bring up initiatives, and explore your own talent in the aspect of precision agriculture. And thirdly, technology is the key to unlock the African agricultural potential. So, for African agriculture to thrive effortlessly, we must leverage the power of technology in terms of precision, bring efficiency, and also make it coordinated. So, why should you join us? We are creating a future we want in agriculture, and we don't want you to be left out. So we also connect you to the world of information and opportunities, which comes down to scholarship, internship, and volunteership on both local and international scale for your career growth. Also, in terms of skill development through project collaboration, research work, community interactions, and workshops. And lastly, we give you access to coaching and mentorship from industry leaders and professionals to actually guide you. That is in your career journey. They are going to be guiding you through where it actually took them 3 years or 4 years or more than that for them to navigate. With the help of mentorship, you can actually do that in a year or two. And that is the power of mentorship. So at Precision Field Academy, we are raising a community of young, tech inclined, and digitally savvy farmers and professionals. Thank you.
All right. Thank you so much, Joseph. That's that's a very good presentation of Precision Feed Academy, the organizers of Precision Agriculture Incubation Program. And we like to reiterate again, what we are about is to actually reach to build a community of tech inclined and digitally savvy farmers, who would actually lead and be players in the future of work in fourth agricultural revolution primarily. So, without further ado, I just quickly want to bring up David Opateyibo, for his lecture. But before that, I want to actually reiterate that, guys, in the incubation program, we have a lot of plans for you this week. This week, primarily we are dedicating it to drone technology. So today is an introduction into drone technology, talking about general and technical considerations. Yes, so tomorrow I would actually be speaking, and I'm looking forward to how David is going to help me lay foundation. Then tomorrow we are going to have another section on drone, and the next we are going to have another section on drone, but different aspects to actually make you a well-rounded drone operator or somebody who is knowledgeable about using drones for precision agriculture. It's very important. So. And later in the week, we are going to be having our first practical, which is simulation class, drone flight simulation class. So if you have actually not registered, if you are actually not registered or showed intention to actually come, please do so. It's going to be, and I'm saying it that after this class with David, maybe we are going to have more interest. We already have folks who have already showed interest, but we need more because our goal is to actually bring this skill closer to you, to actually train more youth to actually be ready, to be leaders, to be influencers. So, David, thank you so much. David, you're welcome. You're welcome. So I'll quickly just read the profile of David before he comes up with his presentation. So David Opateyibo is a drone technology professional dedicated to facilitating remarkable growth and advancement for business through the integration of cutting-edge drone technology into their operations. He offers piloting and maintenance services, consultation, procurement assistance, and customized drone development for diverse industrial needs. With over 300 hours of logged UAV flight time, David brings valuable experience to the table. His expertise span across telecommunication, construction, real estate, topographical survey, energy and oil and gas. Beyond his professional endeavors, David is a founder of Generous, an educational brand committed to nurturing the next generation of drone pilots. Through Generous, he equips aspiring pilots with essential skills, knowledge, and a strong emphasis on safety to ensure the delivery of high quality area services. A round of applause in the comment section, please. I want you to actually welcome David Opateyibo as he takes us on his presentation. Welcome, David. You're muted. Yeah.
All right. Yeah. Thank you so much. I believe you can hear me now. Yeah, it's
Very
an honor
clear.
to be here.
Yeah.
All right. So let's just dive right in. Okay. Good day, everyone. My name is David Opateyibo, and I've just been introduced, so I don't think I need to do any other introduction. Okay. Today we'll be diving into the fascinating world of drone technology and its application in modern agriculture. Right. I'm also happy and I'm thrilled to be a facilitator for this session. All right, so to begin, let's consider the significance of drones in agriculture, right? So why are we talking about drones in the agricultural realm? So let's lay a foundation. Now, the global population of the world, right, is projected to reach about 9.7 billion by the year 2025. And this was an analysis that was done by the United Nations, right? And that also means there's going to be a significant pressure on agriculture to increase food production. Right? Now, according to the Food and Agriculture Organization, this 34% increase in population is going to drive a 70% increase in food demand. So we can see that the growth or the demand for food, right, is not linear with the population growth. So for 34% increase in population, the human race needs to produce 70% more food, right, to meet the demand. So here's the quote from an article released by the FAO on how to feed the world in 2050. In the first half of this century, global demand for food, feed, and fiber is expected to grow by 70%. New and traditional demands for agricultural produce will thus put growing pressure, right, on already scarce agricultural resources.
Now, this begs the question of how do we meet the demands, especially since traditional methods, of providing food, cannot really cover even the demand that we have at present. And that's where precision agriculture comes in. Precision agriculture is the strategy or a precision strategy that optimizes resources, right, by leveraging on technology to increase productivity. So when I say precision agriculture, the word might look vague or too cumbersome, but really it just means you're using technology, right, to augment or to increase your productivity when it comes to agriculture or whatever it is you are doing. Now, drones are an integral part of this, and they offer real-time data collection and analysis capabilities that allows farmers to make data-driven decisions and improve crop management practices. Right. So, in the precision agriculture ecosystem, right, we have a lot of subparts. For example, we have Internet of Things, artificial intelligence, machine learning, and the likes. Drones happen to be one of those systems that are being used. And according to a report by PwC, the market for agricultural drones is projected to reach about 6.21 billion by 2025. That's by next year. The demand for agricultural drones is projected to reach 6.21 billion naira. And the reason for this is the fact that there's an increase in adoption of precision agricultural procedures and also the advancements in drone technology. Now, before we explore further, it's essential for us to understand what drones are and their evolution in agriculture. Okay, so that's what we're going to cover in this section or in this segment. Drones were first developed and used by the military in a variety of applications before they were being adopted for civilian use. Just like many other technology that we use right now, for example, the GPS that we use on our phones and every other thing. Many of this technology first came up right in the military, before they now got commercialized or started being used by civilians and every other thing. So drones also fall into that same category. Drones started gaining traction in the commercial space in the early 2000s, and since 2015, there has been an ever-increasing demand for drone-based solutions, right? So started out in agriculture around 1849 onwards. Then until the 2004, we now had, okay, people now started using drones for like commercial use and every other thing. But then the explosion of commercial drone solutions happened in 2015. Interestingly, drones have been used in agriculture since the early 2000s also, mainly for aerial imagery and mapping. Now, drones come in different shapes and sizes, and this can be categorized into four. So when we talk about drones, so I'm very sure if at all you have seen any drone before, you see that, oh, this particular drone that you saw today is different from the one that you saw tomorrow. Or maybe someone using one in the location, and then you saw another type, and you're wondering, okay, why are all these differences, right? So it's true that we have differences, different shapes, different sizes. But no matter the differences or their shapes or their sizes, they can be categorized into four, right, based on their mode of operation. And these four, sorry, can you see my screen?
Yes, David, we can see your screen.
Please let me know if you can still see my screen.
Yes, I can still see your screen.
Oh,
I can see your screen.
okay.
Are you trying to move it?
All right, no, my mouse was seizing. All right, so let me
Okay.
just start over. Sorry about that. Let's go to- All right.
Okay, it's off the screen now.
All right. Let me just make an adjustment. Sorry about that. Okay, can you see now?
Okay, it's now on the stage. Yeah.
All right. So, like I was saying, so these drones can be categorized into four different categories based on their function. And they are the fixed wing drones, which is what I'm pointing to now. These drones are drones that look like an airplane or fly like an airplane. We also have the rotorcrafts, right? Which are drones that fly like an helicopter and they look like an helicopter. Another one that we have, which is very common in the economy right now or out there, is the multi-rotor drones. And then we also have what we call the hybrid drone, which is basically a fusion of fixed wing and multi-rotors. Now, these categories of drones, right, all have their advantages and disadvantages. Now, for example, fixed wing drones are ideal for large-scale farming due to their longer flight time, right? While on the other hand, multi-rotors are highly maneuverable, making them effective for detailed mapping in smaller fields. So, that, like we already said, there are several options, right, available out there for agricultural operation. But it is crucial to consider a lot of factors when it comes to selecting the drone you want to use. And this includes the farm size, right, the terrain, and the exact task you want to carry out. Companies like Precision Oak, Parrots, and DJI, among many others, provide drones specifically for agricultural use. For example, Precision Oak provides fixed-wing drones and multi-rotor drones for agricultural applications like crop scouting, farm mapping, and yield monitoring. On the other hand, DJI drones specializes basically in multi-rotors that are suitable for crop spraying, field mapping, among many other things. So, depending on what you want to do, that will determine the kind of company you reach out to or the kind of drone you are going to get in the market. Now, this brings us to what we call general considerations, right? What are the things you need to consider when you decide to integrate drones into your agricultural tax cycle, right? So, one of the critical aspects of using drones in agriculture is navigating regulation framework. Drones fall under what we call aircrafts, right? And that under the aviation industry. And in the aviation industry, right, there are laws that people need to abide by, right, to operate aircraft or flying machines and the likes. So understanding these rules and regulations are going to governing drones is crucial for compliance and for safety, right? You don't want to be at the opposite end of the law. So you always want to be law abiding when it comes to your operations so that you don't have any issues. And that's why we're going to first consider regulations. So regulation frameworks. Now, regulation frameworks vary from country to country and from regions to regions, right? Which rules governing stuff like your drone operation, your flight altitude, safety standards, licensing, among many other things. Now, here are some general rules guiding drone operations globally. So even though there are differences, some of these laws apply globally. For example, you cannot fly your drone above 400 feet. That is 120 meters above the ground level. Okay, so if at all you need to fly your drone above that altitude, you need to request for a waiver or a permission, right, to do that. Another thing is you're not allowed to fly, close to airports or where we have or restricted zones like president's lounge and every other thing, right? So where we have high dignitaries or where we have wildlife, in some instances like trade zones or where aircraft operates, where we have high rate of commercial of aircraft operations, right? You don't want to fly in these particular locations. We also have regulations for registering your drone if it weighs above 250 grams, getting a commercial pilot license if you are using drones, right, to make money, among many other things. Now, the Federal Aviation Administration, which is called the FAA, is responsible for regulating drone operations in the United States of America. Their law is called Part 107, right? And it requires pilots who are under that country or that framework to get their license, their pilot certificates, and then follow airspace restrictions and regulations. Similarly, other countries around the world, right, have their own laws and their regulations. Countries like the UK, the European countries, African countries, right, have drone laws stipulated by their respective aviation bodies. These laws often include processing of licenses to operate drones, among others. In South Africa, for example, which is governed by the South African Civil Aviation Authority, their drone laws are called Parts 101. In Nigeria, where I'm from, our drone laws are called drone law parts 21. Okay, so depending on the country that you are, there might be drone laws that you need to follow. Now, it is important to also note that some countries have banned the use of drone altogether. Right? While it is true that drones can be used to do a lot of things and they have a lot of good, in some countries, drones are not allowed. That is, drones are not even allowed to fly. They are banned outrightly, which means if you decide to make use of drones in this particular country, for example, you'll be liable. Additionally, not all countries, right, that provides training or certifications have training programs within the country, right? So even though you can operate your drone in some countries, you cannot necessarily get the licensing that you need in those countries, which means you need to look at alternatives among many other things. All right, so let's dive into the next thing. So remember what I told you that for example, in some countries drones are not permitted. One of the major reasons is because of what we term privacy issues, right? Privacy issues. So privacy concerns arising from drone surveillance have resulted in the development of guidance and best practices for drone operators to safeguard the privacy rights of individuals. All right. Many of the drones that we have out there are retrofitted with cameras, and they can take pictures and can take videos. So many people are skeptical about, oh, someone is monitoring me or spying on me, doing this. So among many other things, some countries have been outrightly banned drones, while in the other countries, even though drones are not banned, there are laws put in place to ensure that these privacy concerns are not violated. Now, the General Data Protection Regulation, which is the GDPR of the European Union, for example, includes provision for the protection of personal data collected by drones. Now, drone operators are required to obtain consent, to ensure data security and also confidentiality. So farmers and other stakeholders must adhere to regulations to avoid any legal consequences. Now, according to a study conducted by AUVSI, which is the Association of Unmanned Vehicle System International, it's an international body, they noticed that over 80% of drone operators believe that complying with drone regulations has a positive impact on public perception and acceptance of drone technology. Right? These laws are basically put in place not to safeguard only the community, but also safeguard you as a pilot and also allow the drone industry, right, to boom and to grow as it's supposed to. Now let's delve into technical considerations, right, which is the technical aspect of drone technology. Now, the very first thing you need to know is drones. Another name for drones, or what we call drones, are UAVs. UAVs, and that means unmanned aerial vehicle, and that's simply because there is no human being, right, inside the drone. So the pilot who operates the drone does not stay inside, but it's outside, operating externally. Now, these drones are a part, and the UAV are a part of what we call the unmanned aircraft system framework. Right? In the unmanned aircraft system framework, we have the drone, and then we have many other accessories. And this includes like your navigation system, right? So you have the drone, we need something to be able to control it. For the drone to be able to navigate, you have a navigation system. You have your communication system, right? What is to control the drone. You have your data link that allows the communication system, right, to speak with the drone. You have your payloads, among many other things. Now, the drone itself also can be divided into different parts, like the airframe, right, like the propulsion system, like the flight control unit, the onboard computer, the communication module, like I said, then the payload, and we also have like the power system, right? For example, many drones operate with the use of motors and are battery powered. And we also have drones that make use of fuel and internal combustion engines. We have drones that also make use of hydroelectric power, hydrogen power supply. So there are a lot of systems or things that you need to put in place, right? So for example, your frame or your airframe, which is the body of the drone itself, is basically the framework that allows you to connect other parts of the drone together, right? You have your flight control system, which is like the processing system or the motherboard of the drone, which controls the navigation. You also have your GPS, you have your communication system, like using radio signals to communicate, using Wi-Fi, among other things. And then we have payloads, which are basically equipment that the drone carries to do the work it does. And like I said, we have power system. Now, these components, they come together and they work together to make the drone fly and carry out the intended task. Okay? Right, so there's still a lot to all these components, but one thing we need to majorly focus on is the payloads. And this is because these payloads are additional equipment that are attached to the UAV to perform a specific task. So you can basically just see the drone as a flying platform, right? A platform that is able to do work. But what makes it more important is the payload, which is the equipment it carries to do the job. So for example, you could have a camera, a handheld camera on your hand, and you take pictures. That's fine, but you are restricted to the ground. Now, putting that camera on a drone to take pictures gives you another, advantage, another opportunity a lesser level of restriction, right, for kind of data you want to capture. So that's why the payload is very important, right? That's the major thing. Now, these payloads can be used for carrying out different tasks, right? We have different kinds of payloads. For example, we have crop dusters, which, or let me say sprayers, right, for spraying chemicals and the like. We have drop mechanisms, which are used to drop packages, among other things. We have the cameras, which are used for taking pictures and videos. And we have other kinds of sensors. Now, one of the major payloads are sensors, which are used for capturing data or data collection. Now, drone sensors also have a wide range of applications, right, including obstacle avoidance. But in this context, we focus on the ones used for data collection. Now, while there are different types of sensors used for data collection, we have five that are the most common, right? And these sensors are the RGB sensors, the multispectral sensor, the hyperspectral sensor, the thermal sensor, and the LiDAR sensors. And these are also the most common one in the agricultural space. I have a couple of others, but these five are the most important or the most commonly used. And I'd like to talk about them a little. Right? So the very first one is RGB sensors. So when we say RGB, we just mean red, green, blue, and that is a sensor that captures images or data just like your eyes will capture it. Right? Basically, what we're talking about is a sensor that captures visible things you can see with your naked eyes, just like the camera on your phone. Right? The cameras on your devices, on your DSLR camera, your Sony cameras, your Canon cameras, are RGB sensors because they basically capture what you can see physically with your own eyes. And they're used for visually inspecting crops and identifying issues like pests or diseases. On the other hand, we also have multispectral sensors, right? And these multispectral sensors are sensors that capture images across various bands of light, including near infrared, that is the kind of light that you cannot physically see with your own eyes. So on my slide here, this first sensor, this particular one, my pointer. All right, this particular sensor, term A, is a RGB sensor. What I have next to it, this is a multispectral sensor, and you see that it has different lenses. So each of these lenses actually captures data for different light bands, including near infrared and stuff that you cannot see, right? And then the data you capture gives you more information about your crop health, among many other things. Now, these sensors help in assessing, like I said, the plant health. They help to detect stress and also optimize irrigation and fertilization by calculating different kinds of vegetation indices. Then we also have hyperspectral sensors. These are more like multispectral sensors, but they capture more wavelength or more, more information beyond what your multispectral cameras can see. And they are used for checking plant biometrical properties, right? So this allows you to detect diseases, nutrient deficiencies, and also environmental stressors. Then we have thermal sensors, which are used to detect heat, like the word thermal, right? Temperature. So they are used to detect the heat signal of your crop, of your plants. And this allows you to identify water stress, to manage irrigation to know that, okay, this particular part of this plant, water is not really getting there. How do we sort that out? They also help to detect anomalies in livestock and assess environmental condition in greenhouses. Okay, and then we have what we call the LiDAR sensors. So what I have here is a LiDAR sensor. This particular one is a LiDAR. It's an hyperspectral sensor. So a LiDAR sensor. So a LiDAR sensor actually uses laser pulses or light pulses to generate 3D maps, right, of a terrain or of a vegetation. And they are used for precision mapping of fields, of contours and terrain modeling. So what this does is the data you capture helps you to optimize land management practices, including irrigation, while also aiding in autonomous navigation. Now, each of these sensor types provide data that help farmers to make informed decisions to improve their crop yield, their efficiency, and sustainability, among many other things. Now, these sensors, along with other kinds of technology, for example, real-time kinematic GPS system, allows you to capture precise data for at precise location, right? And this accuracy enhances the overall landscape of drone operations in Nigeria, in the world instead of Nigeria. Okay, and that brings us to the next topic, which is data capture, processing, and analysis. Right? Already said, to effectively utilize drones in agriculture, a systemic approach is necessary when it comes to data management, because it is the data you capture that allows the farmer to make precise decision they need to make. So we can divide this systematic approach into mission planning phase, into the flight execution phase, the data processing and analysis phase, and then we have the data-driven decision making, right? So the first thing is the mission planning phase, right? Basically, this phase, you are using this phase to decide what you actually want to achieve, right? Yeah, you're planning before you go out there to go and fly. And that when you're doing that, you define the area of interest, the kind of data you want to capture. For example, what altitude you'll be flying your drone, and other kind of settings, right, before you go out there. Now, in the mission planning phase, we have different kinds of software that you can use depending on the drone that you are getting. Two most common ones that we have are drone deploy and Pix 4D. Okay, they're basically used for mission planning. We also have others, but these are two common ones, especially in the agricultural space. And now in the flight execution phase, this is basically when you go out there to capture your data, right? So you go out there, you set up your drone, you fly your drone, and then you capture data. Now during this phase, you are executing the mission you have already planned, right? While adhering to safety protocols. We already talked about the regulations guiding pilots. So when you now go out there now, while you are flying, you are making sure that all your operations are within the confines of the law. Now, when you are carrying out drone operation also, another thing you need to make note of is the weather condition, right? So some drones, for example, are not weatherproof, which means you cannot operate them in the rain. So you have to put all that in mind while you're operating. Okay, is the weather good for me to go ahead and fly? Oh yes, it's good. I have enough sunlight to capture this data, like that. Now, examples of software that will make use of for flight execution include softwares that come with the drone itself. For example, for DJI drones, now we have the app that comes with it, like the DJI Pilot app. You can use that for your mission planning. We also have softwares like mission planners and the likes. Now, remember we spoke about drone deploy and Pix4D, and we said we use them for planning missions. Interestingly, you can also use those apps for executing your mission. So, for example, if you have drone deploy as your software, you can use it to plan your mission. And when you get to the field, you can also use it to capture the data. The next thing is, after you've captured the data, right, and you have gone back to your base, you need to process the data and analyze the data, right? So this data, let's put them into software that allows you to get information, which is basically what you need, to make rightful decisions. So this involves, for example, stitching images together, applying filters, generating various vegetation indices to get what you actually need. And we have different softwares that you can use, and this includes Metashape, it includes MicroSense. If you're using a multispectral camera, for example, we have a MicroSense multispectral camera. So they have a software that allows you to process the data you get from their camera. Another option you have is using drone deploy and Pix4D. So Pix4D and drone deploy are example of software that allows you to do quite a number of things. So you plan, you execute, and then you also use that software, right, to process. For example, we have drone deploy agric, we have Pix4D fields, Pix4D agriculture, right? So that allows you to process your data, and then you gather those data together to make useful decision. And that's the fourth phase, right? Data-driven decision making. So the processed data is analyzed to make informed decisions regarding your crop health, your irrigation, fertilization, and pest management, right? So when you utilize the generated maps and the data, you can use that to optimize your agricultural processes. Some of the softwares that we use for data-driven decision making includes the climate feed view, and also we have Taranis, and also we also have Agrimo. All right, so we have different softwares out there. These are just examples. So this is what you need to know. Digital softwares serve as the backbone of drone-enabled agriculture, facilitating the conversion of raw data into actionable intelligence. Now, while some of these softwares are free, for example, drone deploy, the software for planning your mission is free. The software for executing your mission to an extent is free. When it comes to processing, you need to pay a certain amount of money, right? So for some softwares also, you need to buy them, right? So there's a payment plan for some of them. Some of them offer one-time payment options. Others offer yearly payment options. Others offer, monthly payment options. So while you are setting up your your drone infrastructure, you need to consider, okay, what software am I using? How is my payments plan going to be? And then you look at your budget and many other things, your cost, your budget, before venture into, or before you pick it and stay committed to a particular software. Now that we have explored the different types of sensors and the likes, one thing we need to understand now is the flight principles of drones, right? So we've spoken about the drones, their evolution, and considerations we need to make. All well and good. But now the next thing is, how then do I fly these drones, right? What makes drone actually fly? And that's what we're going to dive into now, because understanding these fundamentals will allow you to become a more effective and safe drone pilot, either in agriculture or any other space that you find yourself. Now, at the heart of every drone flight, we have four fundamental forces, right? At the heart of every drone flight, all drone operations that you see out there are four fundamental forces backing them up. And these forces are, oh, sorry, no, this is, okay, yes, here they are. So these forces are lift, weight, thrust, and drag. Lift, weight, thrust, and drag. Now, these forces govern how drones move through the air and maintain stability, right, during flights. And they are all of them together, like when you take it, lift, weight, thrust, and drag, they are a subset of what we call basic aerodynamics, or what we call aerodynamics. Now, aerodynamics might sound strange to you, but it's simply the study of how objects interact with the air when they move relative to one another. So, for example, if I have a static object here and I have air blowing through it, how do they interact? If I have a calm weather, a calm air, and I have an object moving through it, how do they interact, right? So, the study of how air interacts with the object is all called aerodynamics. So, like I said, we have four forces of flight. We have the lift, we have the weight, we have the thrust, and we have the drag. So let's talk about lift, right? So lift, like the name implies, is basically the force that allows the drone, right, to ascend, right, lift in quotes off the ground, right? The force that allows the drone or the aircraft to lift off the ground to overcome gravity and stay airborne. That's what lift is. The force that allows the aircraft to overcome gravity and float and stay airborne. Now, lift is generated through a lot of principles. For these principles, we have two major principles that guide how lift is generated. The very first one is the Newton's third law of motion, and the second one is the Bernoulli's principle. Okay, so let me explain what the Newton's third law of motion is. So let's take it slowly. So Newton's third law of motion states that for every action, there is an equal but opposite reaction. Simple word. For every action, there's an equal but opposite reaction. Okay? So this means that, for example, if I punch you, there's a high tendency for you to punch me back. That's just it. My action is punching you, your reaction is you want to punch me back. Okay? That's pretty much it. Now let's bring it to flight. Now, for your aircraft to fly, they have wings, they have propellers, and they have rotor blades. So, for example, your airplanes have wings, just like your birds have wings. For your helicopters, they have a rotor blade, which spins right on top of it. And then we also have called propellers, which are what are mounted to, for example, your aircraft engines, right? So we have propellers attached to them, or we have turbofans or turbojets or the likes. Now, the way these fans, these blades, or the way these wings are shaped is called an airfoil shape, right? It's called an airfoil shape. So this is, for example, the cross-sectional area of a wing. So it's an airfoil shape. And when you look at it from the cross-sectional view, what you will note is that the bottom is majorly flat, and then the top section is curved. Okay, so we have the bottom flat, and then we have the top section being curved. Now, what this means is that for Newton's third law of motion, for every action, there's an equal and opposite reaction. Now, because this top is curved and it's curved downwards, when the aircraft, for example, the airplane begins to run, an airplane, for example, begins to run on the runway, right, to take off, air begins to flow over these wings, right? As you begin to, just like you put your hand outside and then you are running, right, you feel breeze trying to blow you, okay? Now, as air begins to flow around you, this time around this airfoil, what happens is that because the top of it is curved, the airflow is deflected downwards, right? So the air is pushed downwards because it's curved, so the air flows downwards. Now this airflow going downwards creates a reaction that pushes the aircraft upward. And since that wing is attached to the body of the airplane lifts off, right? And that's how you get lifts. Now that means the lifts, which is the reaction generated, the upward force has to be greater than the weight of the aircraft. Once that is achieved, your aircraft lifts off the ground, right? And then you are airborne. How would that make sense? So because the shape is curved, the air is deflected downwards, which is the action. The reaction is an upward pushing force, and that lifts the wing upward for you to fly. Now, the next principle is the Bernoulli's principle. Now, the Bernoulli's principle states that if the velocity, that is the speed, for example, of air or fluid increases, if the speed of fluid increases, the internal pressure decreases. Right? Velocity is a principle about speed and pressure. It says if the internal pressure, if the velocity, increases, the pressure decreases. Let me give a relatable example, right? So let's say you are in a confined building with, let's say, 10 people, and then all of a sudden, there's a fire outbreak. And then there is just one door, and everybody wants to run out. Okay? So you have just one door, everybody wants to run out. Now, if all of you hold yourself together and start pushing yourself through the door to come out, what is going to happen is that you people are going to come out slowly, right? You're going to come out slowly because all of you are applying a lot of pressure on that door, and your speed, which is your velocity, is going to be slow. So you'll be coming out slowly, one after the other. But let's say, for example, if you have to come out in an organized manner, right? It's just one door, then immediately all of you line up, and then you start going one after the other, one after the other. If I'm going to come out of that building faster, but you have applied less pressure on the door because nobody is fighting. You're not applying pressure, you're not pushing anybody, right? So that's basically it. So it's saying if my pressure is low, my speed is high. If my speed is high, my velocity is low. So how does this relate to an aircraft wing, you might ask? Very simple. So you have an aircraft wing here, for example, and then your air begins to flow. Now remember, you have an upward section which is curved, then you have a lower section. Now for the lower section, compared to because the wing is curved, right? Because the top of this wing, because it's curved, what happens is that the air speeds up. It's like you are going down. Okay, for example, if you are riding a bicycle and you're going through a down slope, what happens is that your bike accelerates or your car accelerates because you're going through a down slope, which means your velocity automatically increases. So that's what happens. Because the wing is shaped downwards, the speed the air flows over that surface is faster. Because it is faster, there is low pressure generated at the top of the wings. So at the top of these wings, you have low pressure. But at the bottom, because it is flat, the speed is slower compared to the speed at the top because it's flat. The speed at which the air flows over the bottom is slower compared to how it flows over the top. And that creates a pressure difference. So at the top, you have high speed, low pressure, because the air is flowing fast over it. But at the bottom, you have low speed, high pressure. Now that high pressure at the bottom is going to push that wing upward. It's going to push that wing upward. It's more like you have people who are dragging a rope, doing a tug of war, right? The person that has more power will pull that rope or that item to its own direction, right? So because you have low speed here, I have more pressure here, and the pressure is going from the bottom of the wing upwards, right? It pushes that wing upward, and then you have lift off. And now, so in the lifting principle, what happens is basically these forces, once air begins to flow, and then you have the differences and every other thing, it overcomes the weight of the aircraft, which is as a result of gravity, and then it's lift off. Now, weight is simply the opposite of lift, right? So if lift is going up, then your weight and every other thing is coming down. And as we already know, right, weight is basically the force that pushes surface to the surface, pushes an object to the surface of the earth, or pulls an object to the surface of the earth due to its mass and due to gravity, right? So because of gravity, what goes up must surely come down. So for your aircraft to stay airborne, the lift force generated by the wings, by the rotor blades, has to be greater, and then you have that lift. Now, when your weight and your lift is at equilibrium, your drone is your aircraft in this. Your drone does not ascend or descend. So let's assume you have your drone here, and then it begins to fly. At the point where it's lifts off the ground, what happens is that the lift is greater than the weight. Now, when the lifts and the weight becomes equal, that is, let's say it's up here, and then the lift generated is equal to the weight that you generated. So let's say you have a 20 kg, 20 kilogram item aircraft, and then you generate a lift of, let's say, 30 kg for it to come up. Once it comes up, if the lift reduces to the weight, that is, you now have the lift 20, the weight 20, what happens is your aircraft stays on that spot. This is what we call equilibrium, right? Your aircraft stays on that spot. Now, if the lift generated becomes less than the weight, your aircraft begins to descend. Now, the more the difference, the more the reaction. That is, if the lifting force is way more than the weight force, your aircraft begins to ascend very fast. If the lift force is a little higher than the weight force, your aircraft begins to descend, to ascend slowly. If the weight is way more than the lift generated, your aircraft is going to descend, or your drone is going to descend rapidly. If the difference between the lift and the weight is a little different, but the weight is more, your drone, which is your aircraft at this point, is going to be descending slowly. That's pretty much it. I hope that makes sense. So lift is the force generated due to the surface of your wing, your propeller, and every other thing. And this is shape called an airfoil shape, where you have a flat surface at the bottom, a curved surface at the top. To generate lift, use Newton's third law of motion. For every action, equal and opposite reaction. So because air is going downwards, the reaction will pull the wing upwards, or the blade, or the drone upwards. For Bernoulli's principle, because we have low pressure on the top, because we have high velocity on the top and low pressure, right? And we have low pressure below. The low pressure lifts the high pressure at the bottom. The high pressure at the bottom lifts the wing upwards, right? Now that brings us to the other forces. So these forces are counteracting each other. So the lift is counteracting weight, and then the next force we have is the force about thrust and drag, right? Thrust and drag. So thrust and drag are also opposing forces, right? Thrust is the forward force generated by the drone's propeller. So let's say you have your fixed wing drone, for example, or let's take an airplane, for example, right? So your airplane, you have these two engines, these big engines that are attached to it that rotates. Now, as they begin to rotate, what happens is that they deflect air backwards. Because they deflect air backwards, which is the action, the reaction is that the aircraft begins to go forward. Just like what we explained about Newton's principle, right? Every action, you can opposite reaction. So assume you took lifts and weights like this, and then you just flipped it. So your lift now is going to push your aircraft forward. But this time around, we now call this kind of lift, we call it thrust. Now, so thrust is the forward force generated by the drone's propeller, right? And it propels it through the air. The thrust must overcome drag for your aircraft to maintain forward motion. So if I'm generating a thrust, which is a forward force, that's to counter drag. So then what is drag, right? So drag is a resistance encountered by the drone as it moves through the air. If you're in science class, or even if you're not in science class, I believe you've heard about friction, right? And we say friction is the force which opposes, right, motion. So drag basically is more like, okay, what slows down or tries to impede that movement. And it's majorly caused because of the surface of the aircraft, right? So you have a shape trying to move through the air. There's air colliding with the body of that object. Because it's colliding, it's kind of slowing it down, right? Slowing it down. So drag is that force that tries to push or resist the movement, right, through the air. It's caused by friction and due to rough surfaces and every other thing. It acts in opposite direction to thrust. and must be overcome to maintain forward motion, to maintain forward motion. So, like we said about lift and drag, right? If the thrust is far greater than the drag, your aircraft accelerates. At least it begins to increase in speed. So let's say moving forward at 20, it accelerates 20, 30, 40, 50, 60, 70, like that, it begins to accelerate. The point where your thrust equals to your drag, your aircraft does not accelerate, but it maintains that constant movement. So, for example, if you're driving a car now, for example, you're driving a car and then you press the gas, right? Which means you accelerate. What's happening is that your forward motion now is more than the drag that you're getting. So you're speeding up. By the time so let's say now you decide that you want to maintain 60 miles per hour or 60 kilometers per hour, right? What's happening is that at that 60, your forward force, your thrust is equal to the width of the aircraft. So you're not descending, you're not accelerating, you're just going forward. Now, once your thrust becomes less than the drag, you begin to slow down and it must begin to move in reverse, right? If it happens, if you get to that point where it is way more, you need to move in reverse. Okay, so that's pretty much it. So thrust is the forward force entered by a propeller that moves your aircraft through the air. Drag is that resistance, right, to that flow. And that's the reason why, for example, sport cars are shaped the way they are. So I don't know if you have encountered something before where, let's say, you hold a flat surface. If you hold a flat board, for example, and you begin to run with it, like to run, you notice that there's this pull trying to slow you down, and that's because of the barrier, right? You have a wide barrier, a very big barrier. But if, for example, now instead of holding the item, let's say instead of holding the item like this, try to hold it like this. Because you have less surface area, it moves faster through the air. That's the reason why jets are shaped differently from how other aircraft are shaped, right? It's more streamlined to reduce the friction. Same thing with your sport cars and every other thing. So I believe that allows you to understand the concepts better. So let's move over to the next thing, which is the three axes of flight. The three axes of flight. So your drones have the ability to move in three axes, right? So we live in a three-dimensional world. So your drone can move within those three dimensions or three axes. So the very first one is your pitch or your lateral axis. So this is what you have here. So your pitch or your lateral axis. So these are to explain the axis. Just imagine you have an aircraft here, or you have a drone here, and then there's an imaginary line that cuts through from left to right. I think this is a good example. Can you see this? All right, so let's assume you have an imaginary line that cuts through from left side, from the right side to the left side, right? Whatever way that cuts through. So this means that if there's an imaginary line here, your drone can move this way or move this way, move this way or move this way, move this way or move this way. That's the pitch. So pitch means nose down, nose up, front down, front up. More like you're nodding your head, right? Nodding your head. That's the motion. You can nod your head. So that is pitching. And there's an imaginary line here. So it's around this line that this aircraft is moving, right? Around this line. Now the next one that we have is the roll axis, or what we call the longitudinal axis. So longitudinal axis simply means from the forward to the back of the drone, right? From the front to the back. You have your longitudinal axis. If I have an imaginary, let's say, a rod passing through here, it means my aircraft can either roll in this direction or roll in this direction. Roll here, roll here. So that's what roll is. Roll simply means you're moving your drone this particular way, right? This way and then this way. That's the roll axis. And then the last one that we have is the vertical axis, or what we call the yaw axis. The vertical or yaw axis. So simply means you have like a rod, for example, vertically, yeah, and that means your drone can turn this way, right? So this is the yaw motion. And then we have the pitch motion, which is about the lateral axis, which is side by side. You have a line side by side, so the drone can only go this way. You have a line this way, the drone can go this way. Now with the roll axis. And then you have a vertical line, which means your drone can move about this direction. That is your your axis. Okay. So for your axis, you're turning the drone left and right, more like you're facing front, and then you face your right, face your left. That's your yaw motion. Like I said, your pitch motion, liken it, you are nodding your head. So nose down, nose up, nose down, nose up. And then your roll motion is simply turning your head, touch your shoulders, right? So that's your roll motion. Now, so different types of drones exhibit variations on how they control movements across this axis. Okay. So fixed wing, for example, makes use of what we call control surfaces. Fixed wing makes use of control surfaces, right, to control the deflection, to deflect air and then allow their movements. While multirotors makes use of what we call speed differentials, right, or thrust differentials. So we're adjusting motor speed, but we're going to talk more on that. Okay, so let's go to the next thing. Drone operations. So in this section, I will delve into the world of drone operations, right? How drones are operated, how drones fly. And the first thing we start with, like I said, is how we control the multi-rotor drones. Like I already said before, the way fixed wing work is the mix of control deflections, right? On the surface is to deflect air. For multi-rotors, makes the work called thrust differentials or speed differentials. That means we have 4 controls. That gives us 4 controls, right? Because of all this that we have said, we have 4 ways we can control our drone. We have our pitch, which I spoke about before when I was explaining the 3 axes of flight, which is nose up and nose down. So basically, for your pitch control, you have your nose up and your nose down. We have the throttle. Okay, we have I've gone ahead of myself. So we have the pitch control, nose up and nose down. We have the roll, which is moving left, which is turning your drone left and right. And then we have the yaw, which is twisting your drone like this. And that gives us the 4th one, which is called throttle. So your throttle control is basically a control that allows you to ascend and descend. So throttle does climb up, climb down. So you can either climb up or climb down. So you basically have 4 movements now, right? The 3 axes gives you 3 movements. And then you have 1 extra, which is the movement up and down. I believe that makes sense. Pitch, yaw, roll, each of the 3 axes that we have, right? The Y, X, and Z axis. But then we now have the one that allows you to now go up vertically. That gives us the 4 controls, right? So now in this section, we'll be looking at how multi-rotor drones are controlled. We have how, I can explain how, we have how airplanes fixed wing are controlled. We have how rotorcraft are controlled. But I'm sticking with explaining how multi-rotors are controlled, and that's because they are often a starting point for many enthusiasts and farmers, which is that simplicity and stability. So before you go into the intermediate stuff or the more advanced stuff, learning about how these are controlled, like kind of lay the foundation for every other thing. Let's talk about that. So like I already said, we have 4 controls: your throttle, your pitch, your roll, and your yaw. Right? Now, this brings us to explaining how this thing works. So the very first thing now is your throttle. Remember I said the motor are controlled based on thrust differential or motor speed differential. So now you have the propeller, which are attached to the drone, which are basically the blades that are shaped like an airfoil, right? You have your propellers are shaped like an airfoil and they are attached to the drone. So for example, you have these blades here and you have these blades here, right? If you look at this, so you have these blades here now. So this begins to rotate. Now, for this one, we have 4 blades. So this is a drone, for example, now. So we have blade 1, we have blade 2, blade 3, then we have blade 4. So we have 4 blades now. As these 4 begin to rotate, and they are rotating at equal speed. Remember the word equal speed. So they are rotating at equal speed. Because they are rotating at equal speed and they are designed the same way, the drone, if the force it generates becomes more than the weight of this drone, it climbs up. Right? It climbs up. Now let's say it's up. If the lift force it generates becomes less than the weight of this drone, it begins to descend. That's your throttle control. So when you control your throttle, you're controlling the speed of all the motors together, same speed for everything, increasing the speed of everything equally, or decreasing the speed of everything equally. If you increase the speed of everything equally, the drone will ascend. If you decrease the speed of everything equally, the drone will descend. Right? Spot on, smooth and sweet. Now that brings us to the next one, which is your pitch control. right? Your pitch control. So basically, for your pitch control, you basically want, when your drone is pitching forward, it goes to the front, it moves forward, right? So it's pitching forward, so it goes forward. It's pitching back, it goes backward. So it goes backward like this, pitch forward, it goes forward like this. So how does it do that? So we have the forward motors and then we have the backward motors. So let me use the diagram here to illustrate. So now you have the forward motors and then you have the backward motors. Now note this. The color red on these images means high speed, danger, high speed. The color green here means low speed, safe. Just take it like that. Now, for forward motion, what is happening is that the motors at the front are reducing in speed equally. Right? So the two motors in front reduce their speed equally, while the two motors at the back increase their speed equally. Now, because these things are rotating, the motors at the back are rotating faster, they are generating more lifts than the motors in front. So if I have more lifts at the back, what happens is that the back of my drone comes up, right? The back of my drone lifts up. So when it lifts up, the forward one descends, goes down. So I have this kind of movement, and then my drone begins to move forward. The reverse happens when I am pitching backwards, right? So when I'm pitching backwards, what happens is that the forward motors increase in speed, while the backward motors decrease in speed. Okay, so we have this forward motion, go this way, then backward motion, go that way. Okay, now this brings us to the roll. Now for the roll, what basically happens is that we are controlling the speed of the motors one side and then the other side. Okay, for your roll, I control the speed of the rightward motors against the leftward motors. So what happens is that if you want to roll, for example, you want to roll to the right, what happens is that the speed of your right motors, the two right motors, increases equally, while the speed of your right motors decrease equally. Once you roll right, the right motors decrease in speed equally, the left motors increase in speed equally. That raises the left side because they have more lift, and then your drone rolls to the left, right? The inverse is the case for rolling right. So for you to roll right is different from for you to roll left. So if you want to roll left, speed motors of the right increases in speed, and then the motors on the left decreases in speed, and then you roll left. Now that brings us to yawing. So for you to yaw, simply means you are changing the heading, which is where the drone is facing. So you're changing the heading of the drone, right? So how do you achieve this? To explain this, and to take a look at, I don't know if you've seen in movies where an helicopter is flying and then they shoot the tail of the helicopter down. I don't know if you have seen that. So basically what happens is, if you have an helicopter flying, helicopter usually has a rotor blade, and it has a blade at the tail, right? So in most movies, when you see them trying to attack an helicopter, what you see is that they either try to shoot the rotor blade or they try to shoot the tail. In instances where they shoot the tail, what you notice is that the drone, the helicopter in this instance, spirals down. It rotates while it's standing. It rotates down. Now, the reason is because that tail actually helps to balance the effect of your rotating blades. Let me explain. So, for your drones now, you have a blade that is rotating. Now, this blade can either rotate clockwise or counterclockwise. The blades can either rotate clockwise or counterclockwise. It can only rotate in one direction, right? So let's assume it is rotating in a clockwise direction. What do you think is going to happen if you make reference to Newton's third law of motion that I was talking about before? It means because this is rotating clockwise, there is going to be an anti-clockwise reaction, which means because this blade is rotating clockwise, the body of your object wants to rotate in the opposite direction of the rotation. So as this is rotating clockwise, the body will be spinning in the opposite direction, right? So for your helicopters, what they do is they attach a tail rotor to counter it, right? So while the thing wants to spin to this direction, this tail rotor will be countering it and providing that stability. Now for your multi-rotors, what happens is that we have equal number of blades that rotate clockwise and equal number of blades that rotate anti-clockwise. Okay, look at this diagram here. This explains it better. In this diagram now, we have 1, 2, 3, and 4. So you notice that diagonally, we have two different rotations. So diagonally, 2 and 4, you can see that 2 and 4, they rotate anti-clockwise, while 1 and 3 rotate clockwise. Like 2 and 4 rotate anti-clockwise, while 1 and 3 rotate clockwise. Now, if everything is rotating at the same speed, it means they're countering their effect. For example, if all the motors, if all the blades, if all these blades are rotating clockwise, it means automatically, no matter what you do, your drone will constantly be rotating in the opposite direction, which means you'll not be able to control it. It will be unstable. Right? Well, because I have two that are rotating clockwise, and they are creating an anti-clockwise effect, right? They want the drone to move anti-clockwise. But then I have another two that are rotating at that same speed, and they want the drone to move in the opposite direction. They cancel out each other. So this is pushing 50 pounds of force. Say go left, go left, go left. Something is pushing 50 pounds of force. Say go right, go right, go right. 50 minus 50 equals to 0. So your drone just stay on that spot. So for motors to yaw, what happens is that we now increase or decrease the speed of the clockwise motors against the anti-clockwise motors. So if we increase the speed of the clockwise motors, your drone will rotate anti-clockwise. Make sense? So by increasing speed of the clockwise motors now, my drone will rotate anti-clockwise, which is the opposite reaction. If I increase the speed of the anti-clockwise motors, which is the action, anti-clockwise is the action, my drone will counter that opposite reaction, will rotate clockwise. I believe that makes sense. So that's basically how your drones work. So you have, for example, in this instance now, you have 4 motors, which makes this a quadcopter. We also have instances where we have 6 motors. We have instances where we have 8 motors, right? So it's pretty much the same thing, basically. You are increasing the speed of the clockwise against the anti-clockwise, or anti-clockwise against clockwise for you to yaw. All the forward motors rotate at higher speed or lower speed compared to the backward motors for you to pitch. All the left motors increase in speed or decrease in speed compared to the rightward motors for you to roll, right? And then for you to ascend and descend, what simply happens is you are increasing the speed of all motors equally or decreasing the speed of all motors equally. Right? I think that makes sense. Okay, so let's go to the next one. All right, bring us to the next question. How then do we control, right, this movement? How do we control this motion? And that's where this comes in. So we make use of radio transmitters to send these signals or these control signals to our drone. Remember when we were listing the when we're talking about the unmanned aircraft system framework, right? We said we have the drone itself, and then we said we have the communication and data link system, we have the navigation system, and many other things. So to control the drone, we make use of what we call a control system, and that's what we call the radio. People call it the radio transmitter, or they call it RC, right? Radio transmitter or the RC. So basically, it's more like a, let's say, a PS2 pad, right? More like a pad, like a Game Boy pad, right? And then you have joysticks on it, and then you have a lot of buttons on it, right? So each of these control, for example, your throttle control, your pitch control, your yaw control, your roll control is assigned to a channel. I will explain that, right? It's assigned to a channel. Now, and that means if each control is assigned to a channel, that means I need at least 4 channels, right? So on my controller, I need 4 channels. 4 channels just means 4 buttons, for example, or 4 controls, 4 movements. So I have the throttle channel, I have the pitch channel, the roll channel, and the yaw channel. So at a minimum, for all multirotors out there, I need to have 4 channels, right? But the thing is, transmitters usually have more than 4 channels, right? These channels, all these other channels allow you to do other things. For example, you can have a pitch channel that allows you to control the landing gear of the drone. At least maybe it has a retractable landing gear or retractable wheel. or maybe you have a channel, for example, for let's say you're doing as a light for turning on and offing the light. For example, if you are using an agricultural drone like dust crops, right? You have a channel that allows you to on and off the pump. If you have a camera attached to your drone, you have a channel that helps you to capture picture back or capture video, or you have a channel that allows you to move the camera up and down, left and right, like many other things, right? So you can have an 8-channel transmitter, a 16-channel transmitter, a 12-channel transmitter, it doesn't matter. The minimum is that you have 4 channels: your throttle, your yaw, your pitch, and your roll. These are usually assigned to a joystick. So let me, okay, so if you look at this picture on my slide now, this is an example of a transmitter. And then you have this joystick here, and then you have this joystick here. So you have 2 joysticks. You have the left joystick, and then you have the right joystick. The thing about this joystick is that the joystick can move up and down, left and right, both of them, up and down, left and right. So you have 4 movements. So up and down here is 1 channel, left and right, 1 channel. Up and down here is 1 channel, left and right is another channel, right? So that's pretty much it. So this is a transmitter, for example. Let me explain it. So if you look at this one now, you see channel 3 throttle, which means the up and down of this button. This joystick taking it up or bringing it down is 1 channel. Channel 4 here, if you look at it, it says rudder. So if you take this left and right, you have the rudder control, which is basically your yaw, right? So you have your yaw, turning your drone left and turning your drone right. Now this is on the left button for this one. Now on this right button now, you have an aileron channel, which is your roll channel, right? So left and right, which means roll right, roll left, and then you have your elevator channel, which is pitch forward and pitch backward. Pretty simple. Right now, here's the thing. See, this channel is here. If you look at it, this control here allows you to control your drone on a spot. So you have your drone on a spot, right? So on that spot, if you take this throttle channel and you go up, your drone lifts up on that spot. So your drone goes up on that spot or descends on that same spot. Now, if you have your rudder control, so your drone, yours, so yours left or yours right, it basically turns, right? Either clockwise or anti-clockwise on that same spot. But then on this your right joystick, your drone moves, okay? So for your pitch control, which is the channel 2 on this one now, your pitch means if you take this stick and take it forward, your drone is going to go forward. If you take this stick and move it backwards, your drone is going to go backwards. Right? It's pretty simple. Makes sense. Everybody can fly a drone. Okay, just kidding. All right, so this is, you get it now. So now this one allows your drone to move away from a spot, and this allows you to control your drone while it's on one spot. Now you can combine the controls together, but that's the basics of it. But here is the thing. What I just explained to you now is called a mode 2 transmitter setup. I know it's a lot, but just take a breather, right? Just take it one at a time. So we've already explained that this throttle, your throttle and your yaw, can control your throttle allows you to go up and down on one spot. Your yaw allows you to rotate clockwise and counterclockwise on one spot. So you basically took those controls and put them, bam, on the left joystick, right? On one spot, up and down, left and right, on one spot. Then here, now you have go forward, go backwards, go left, go right, right, on this joystick. So that's how they divided it. But now we now have other modes where the mode simply means the arrangement, okay, the arrangement of these controls, right? So look at this now. Look at this image here. See that what I just explained now is a mode 2 transmitter. So you see throttle, which is here, channel 3, throttle, your other channel 4. And that happens on one spot, right? So that is your left joystick. Now your right joystick, you have pitch, which is go forward and go back. And you have left and right, which is go left and go right. It's exactly like this one. Aileron, which is your roll, left or right. Elevator, go forward or go backwards on this other controller. But look at this mode 1 transmitter. What you will notice is your pitch, which is up and down, is here, but your yaw is also here. So what they did was they took this throttle control, this pitch control that we have on the right stick, they moved it to the left stick, and then your throttle that is on the left stick, they moved it to the right stick, right? So Basically, now if I go like this, this is move forward, this is move backward, this is turn on the spot, this is go up, go down, this is, you get it, roll left, roll right. So the arrangements or where those controls are, that's changed. We also have mode 3 transmitters and we have mode 4 transmitters. So mode 2 is the most common, especially in this realm. In some European countries like Germany, for example, mode 1 is common, right? But mode 2 is common, so let's stick with that. Don't complicate it. So your rudder and your throttle, your yaw and your throttle are controlled by the same stick, which is the left stick. And it's, you do that, and this control is for on the spot. This other control are things that you control that move your drone. So forward and backward, which is your pitch. The drone going far away from you or coming towards you, for example, if you are facing the same direction as the drone, or the drone going to your left or going to your right, if you are facing the same direction of the drone. Aha, hope you hear what I said now. If you are facing the same direction as the drone. So here, for example, it's your drone is moving. So if my drone, and bring this back. So if this drone now, this is a drone here, for example, and it's facing the same direction as I'm facing, right? So when I say go forward with my right stick, the drone goes forward. Every time around, it is with reference to my front. If I say go backward, it comes to me. If I say go right, it goes to the right, which is also my right. If I say go left, it goes to the left, which is also my left. But now let's say, for instance, I turn this drone this way, right? So now this drone is facing, this drone is facing my right. Okay, so now this drone is facing, it's facing my left right now. So if I say go forward, what happens is that this drone goes to its own front. Can you listen to that? It goes to its, not my front, its own front. So when I'm controlling the drone, I'm controlling the drone with reference to the drone and where the drone is facing. If I say go front now, the drone is going to its own front, but that is going towards my left. If I say pitch backwards, the drone is going to go back, right? But that back now, it is to my own right. If the drone were to face me, for example, and I tell the drone to go front, what it is facing me, it means it's going to come towards me, going front. If I say the drone to go back, right, it's going to go away from me, because away from me, it is the back of the drone. So same thing for your roll, right? If I say roll to the left, if I'm facing the same place as the drone goes that direction. So I say roll left, the drone rolls to my left, which is also its left. I say roll right, the drone rolls to the right, it's also its right. If the drone were to face right, face left like this. If I say roll right is going to go to the drone's right, but it's far away from me. If I say roll left, it's going to go to the drone's left, but the drone's left now means the drone is coming towards me. I believe that makes sense, right? So let me just show you what a typical transmitter looks like. So I have one with me. All right, so this is a transmitter for one drone. Okay. Now you see that I have two joysticks here. So I have two buttons here, right? So this stick, this right now, like the drone facing me like this, right? This stick controls my throttle, a mode 2 transmitter. So just reference this. Mode 2 transmitter, this controls my throttle, and this controls my yaw on the same spots. While this controls my drone going forward, drone going backward, and then it also controls going left and then going right. Okay. But if you see also, you see that I have other buttons, right, on this, and all these are assigned to other functions on the drone. And then, yeah, of course, this particular controller has a screen, right, that allows me to use an app just like this particular one. So the joystick allows me 4 channels: drone, go up, go down, go left, go right. Now, so here's the thing. The farther away I move from the center, so see the center as 0, right?
David.
The farther away I move from the center is the
David.
faster the drone responds. Remember when
David,
I was talking about lifts and weights? I said the more the lifts, the faster the drone will climb, right? The more the lift compared to the weight, the faster it will climb. That's basically what this allows you to control. So this controls your throttle, right?
David, you can
This is your
see.
throttle, which is
Okay.
fine. But then
David, can
if
you raise it up?
I arm my drone and then I say I fly and then my drone is on the spot. If I take this just up a little, because the lift is now more than the weight, the drone will begin to climb. But because it is just a little difference, it climbs slowly. If that makes sense. Now, if I take it all the way up, it means I'm generating the maximum amount of lift I can generate. Because that difference now is higher than the weight, way higher, it's going to climb very fast. Same thing goes for if I am coming down. Right? If I'm descending, if this stick is taken down just a little, my drone descends gradually. It's taken down pretty fast, I don't descend rapidly. So let's say, for example, now I'm coming to land my drone. I've flown, I've got data, and then when it got time for me to land, I just took this stick, I took it all the way down. If my drone is not smart, right? If it's just a regular drone and it's manual control, what happens is immediately I do this, the motor shut off, or it drops so rapidly that when it hits the ground, something gets damaged, right? So it's all about minute control, simple, basic control. It's time for you to move fast, of course, move fast. But when it comes to some actions, for example, like landing, you want to land as slowly as possible. Sometimes
Hi,
you want
David.
to take off, also want to take off as slowly as
Hello,
possible.
David.
This same thing also applies to
Hello, David.
rotating
Can
clockwise
you
and
can you
anti-clockwise, going front and back, going left and right, right? The farther away it is from the center, is the more responsive the control is. I believe that makes sense. Okay, so let's go to the next thing. All right, now this brings us to what we call flight modes and fail safes, right? So now when it comes to drones, I've already stated, right? We have drones that are built for different categories of drones, first off. Now the thing is, even within the categories of drones, we have drones that are built for different things, right? So we have a drone, for example, now that is carrying a camera, an RGB sensor. But now you have another drone that is carrying a spreader or a sprayer. And then you have another drone that is carrying a drop mechanism, right? Now, each of these payload that it is carrying, which means it can do different things. Now, sometimes what happens is that the manufacturers, based on the function these drones perform, create flight modes that are suited to those operations. Okay. Now, apart from your regular control, now can I have these assisted modes or this automatic flight modes, or should I say intelligent flight modes, which is making use of artificial intelligence, right? Intelligent flight modes that allows you to control the drone or that allows the drone to perform a function automatically all by itself, right? Now, also about what we call fail safes. Fail safes are simply like safety settings or safety modes that are included into the drone to prevent, accidents or incidents and many other things. Now, let's just take a look at some of them. All right. So, for example, we have what we call manual mode. Now, many drones are equipped with what we call a global positioning system, a GPS, just like a GPS on your phone. It allows you to track its own location. So, you have a drone with a GPS, which means when you turn it on and you leave it on the ground for a while, it gets connected to satellites. The satellite allows you to know its location, so it knows its longitude and its latitude. And when you check a map, for example, when you check the map on the app, you're going to see an icon of the drone showing you where the drone is. Now, the drone already recorded its own points now. Good. Now, in a GPS control mode, it means it is making reference to the GPS, which helps it to know its location, among many other things. For example, the compass, the IMU, don't worry about the gibberish. So basically, it allows it to make some of those systems, right, to know its location and also its movements. So, for example, if the drone flies away from you, far away from you, because on the map, it already knows its location, the special functions you can do, right? Now, you have a GPS which allows you to know its location. There's what we call manual mode. In this manual mode, you're not making reference to the GPS. And in fact, so many times when you're flying your drone is basically assisted, right? It's assisted. For example, if you roll to the left and you leave your controller, after a while, the drone just stabilizes itself, right? If you pitch forward and like that, after a while, if you leave your controller, the drone automatically stabilizes itself. So basically, when you're flying, most times it's autonomy, right? So it's you and the drone working together, right, to make everything work. They're being assisted by the drone sensor, by the drone brain and the drone body. When you switch to manual, you're basically saying you don't want the drone system or the software in it to assist you. You're taking manual control. So most times, no GPS, no compensation, it's all on you, right? You can try to do that if you want to. Now, we have the one that allows you to have a little bit of GPS, but then you get to have different kind of modes like that. Now, some drones also have what we call obstacle avoidance sensors, right? Which means it allows you to detect obstruction and then it automatically augments. So, for example, if you have an obstacle avoidance sensor at the forward of the drone, but this one, let me just use an example. So, if you look at this drone here, so this is the camera, it's quite covered now, but you see we have some stuff that look like lenses that look like camera here, and these are actually obstacle avoidance sensors. Now, what they do is they kind of capture images or videos real time, but they're not saving them. It's using that noise location with reference to an obstruction. So when you are flying, let's say close to an obstacle, it senses it based on the settings that you put on it to tell it what to do. So for example, an obstacle avoidance sensor, if you set it that okay, 5 meters response, it means if that drone gets up to 5 meters close to an obstacle, it stops. It prevents you from hitting that obstacle. Not all drones have obstacle avoidance sensors, right? So now, what I'm trying to explain is, depending on the kind of drone you have, you have other functions you can do. Now, the thing is, you can turn this off, you can turn it on. Another thing you can do is, let's say you are using a drone for photography and videography, and then you have a real estate apartment, and you want to orbit, that is, do 360 around it. You can decide to do this manually, right? So basically, you take your control, and then with your combination of controls and everything, you're able to rotate the drone manually while you're taking videos of that environment. But let's say you don't want to do that. You don't want to go through that stress. The drone that you get, for example, can have what we call point of interest. This simply means you go over the place you want to capture, you go over that altitude, you mark it as the point of interest. So you're going to use GPS, right, to reference that point. And then you come outside, you pan out, and then automatically you start the mission. What it does is automatically the drone, without your input or control, begins to circle around that building while taking the video. It's assisted. So those are assisted flight modes. We have a lot more. We have like waypoints. For example, if you are doing mapping of your agricultural farm on field, you can have waypoints, or you can have mapping tile. Basically, you're just saying point A, point B. Basically, mark an area, and then the drone will fly across that area and automatically capture pictures, right? And then you can use that to generate your maps for vegetation index, crop analysis, among many other things. So I'm just saying that to say that different drones come with different flight modes, right, that you can make use of. So you have your normal mode, your manual mode, many other things. But then we have what we call fail safes, like I already said before. One of the most important fail safes that you have on many drones is the RTH fail safe. RTH simply means return to home, right? Return to home. As I already stated, now, if your drone is equipped with a GPS, it means when you turn it on and you use it for a while, it gets satellite connection. Satellite connection allows it to know where it started off from or where it was turned on from. Now, it marks that place as its home, right, as its house. So let's assume now you now fly, and then you've flown pretty far away, and let's say you cannot see your drone anymore. Now, when you're talking about regulations, you're supposed to fly your drones while you can see them, right, within your visual line of sight. But let's assume you cannot see your drone anymore, but you don't even know where the drone is or something. You can press return to home. And what happens is that automatically the drone will turn, face home, come to where it took off from at a high altitude and descend and come and land around where it took off from, right? So that place is marked as home because it is GPS equipped. It can find its way by itself. It's like a child returns to the market and they say the child does not know the way back home, right? But this time around, if the child knows the way back home, even if it's kind of lost, no matter what, he will always find his way home. That's pretty much it. So if the drone is equipped with GPS and you're allowed to record the home point before going, if you are lost or you don't know what you are doing anymore, you can press return to home and it comes back. Now, here is the fail safe part of it. Let's assume you were flying, and all of a sudden you lost connection to your drone. So no connection to your drone at all. Try to make connection, but no connection. And then drone is just outside there, just airborne. Two things can happen. Now, if for example your drone is not equipped with return to home function, and you do not, let's say, go and find it, go and look for it, to go and regain connection, or even where you are, you cannot regain connection anymore. What is normally going to happen is that the battery, wherever it is, this is still flying, will deplete. And then once it depletes, your drone is going to come down and land wherever it is. That can happen. Even with return to drones that return to home function, it happens too. But let's not talk about that. So now let's assume that, okay, now you've flown the drone far away, and this time around you've lost connection. Many of these drones, the way they are designed, they are programmed such that after losing connection for a certain amount of time, let's say for example 1 minute, if the drone sees that there's no communication, it can't sustain communication between you and it automatically turns back and returns to home. So imagine if your drone was not equipped with the GPS. Of course, they equip the GPS now, you can do that. Here's another thing. Many drones also are equipped with intelligent flight batteries. So when the drone is flying, the drone knows as it's going, it's calculating the amount of batteries it needs to return back home, right? So if you're not flying too far, for example, let's say your drone can fly for 30 minutes, and you're just staying, it's rated for 30 minutes, and you're just staying close to you, right? If you leave your drone, just leave it there, leave it hanging to fly, let's say for like 29 minutes or so, and then once it gets that low battery, it lands. But then let's say it descends at 5%. Now, if you're flying pretty far away, right, and then you use up your battery for long and everything, now it's calculating the amount of battery it needs to come back. So let's assume if you flew 1 kilometer away, for example, it might automatically come back home to you at 15%. If you flew very far away, let's say to 2 kilometers, just an example, it means it might come back to you at 20% because it needs that much battery you get to return back to you. So it's automatically calculating the amount of battery it needs to come back to you. So that's a low battery fail safe, really. So once the battery is low to an extent, if you see that it cannot continue the mission, it returns to home. Of course, you can override it, but that's your own safety risk. Okay. So you have all those kind of features and all those kind of things that are incorporated into your drones, for better setup or better operations. Okay. Let's go to the next one. Okay, so this brings us to safety considerations. Right, so we already understood, okay, this is how drones fly. Okay, this is how I need to fly my drone. These are the regulations I need to put in place. So safety is paramount when it comes to operating drones in all cases, including agriculture. Safety is very paramount, right? We've already discussed regulations guiding drone pilots, but let me buttress on two. The very first one is always maintain visual line of sight with your drone at all times, right? Because this allows you to know when something is wrong and be able to physically see it so that I can correct it, right? So imagine flying behind a building, for example, where you cannot see your drone anymore. Because you've lost orientation, you can decide to make a wrong move, and your drone hits the obstruction, does not have a particular avoidance sensor, and then you damage your drone, or you kill someone. You get to always fly within a visual line of sight for situational awareness. Another thing is to avoid restricted airspace as much as possible. Well, for those who are working in the farm, there's a high chance, okay, you'll be working in your farm, right? So it's your land, it's your permission and everything. But then if, for example, let's say you're operating outside your vicinity, always know about the regulations of that area. Are you permitted to fly or not? What are the waivers you need to get before you fly in those locations, right? So you need to have all that. To avoid restricted airspace, obtain permissions when necessary. One other thing you need to do is that you need to carry out periodic maintenance. All right, so you're making use of your drone, and your drone is an equipment, it's a gadget. So it can get faulty, it can malfunction, it can have different kind of issues. You need a firmware updates, all those kind of things. So while you're operating your drone, it's more like you take care of your drone, you don't take care of you, right? So you maintain it, you take good care of it, you clean it up, you take it to a repair person to help you to maintain it periodically, change the batteries when you need to, and all those kind of things, right? Don't operate when it's malfunctioning. So you put all that in place, and that will allow you to carry out your operation seamlessly and easily. All right, so that brings us to another topic, which is the integration of drones in agriculture. No, like we've already been saying from earlier discussions, I believe you have pinpointed some stuff and already evidence that drones have numerous applications in precision agriculture. These applications include crop scouting, disease detection, weed management, and yield estimation. Now, to help understand better, let's explore some real-world use cases or case studies that demonstrate how drones have been successfully integrated into various agricultural practices. These case studies highlight the improved yield and the resource efficiency experienced as a result of using drones in the operation. So we're going to start with the very first one, which is the coffee plantation management in Brazil. The coffee plantation management in Brazil. All right. So in this particular use case, what happened was that a set of coffee growers in Minas Gracias, somewhere in Brazil, implemented a project right in 2018 to enhance coffee quality and optimize cultivation practices. The purpose of doing this was so as to increase farm productivity, right, as always. So they employed a drone which was equipped with a thermal imaging camera. Remember we spoke about sensors, spoke about different kind of sensors. Now in this use case, they used a thermal imaging camera. So when they use the thermal imaging camera to carry out their data, they use that to capture the canopy temperature, right, to monitor the canopy temperature and the variation across their coffee plantation. Now, the data they got from this thermal imaging, right, allowed them to estimate or to figure out the drought stress and adjust irrigation strategies. So because of the heat signal or the heat data that they got, they're able to look at, okay, this is drought stress. Okay, we don't have enough water reaching this area. That's why this is yellow, or it's not illuminating light as supposed to illuminate light, right? It's not reflecting as supposed to reflect. Oh, yeah, it's pretty green, or makes sense, right? So they use those data to understand the drought and then strategize for irrigation. Another thing that it helped them detect was allow them to detect pest infestation in their coffee trees, and that allowed them to create targeted pest control measures and minimizing crop damages. Right, so the implementation of drones here allowed them to increase the quality of their coffee production and enhance the reputation of their market value. Okay. Another one is the rice field management in Asia. So there are these rice farmers in Vietnam and Thailand. So they created a cooperative, right? So that's what many small scale farmers do, right? They create a cooperative where they come together and they formed a cooperative and implemented the use of drones equipped with LiDAR sensors, right, in their rice cultivation practices. The use of LiDAR sensors. Now, with LiDAR sensor, what they did was they used that drone to create a 3D model or a 3D mapping of their rice paddles to optimize irrigation strategies. The project was launched in 2019 and they carried out periodic monitoring, right, during a particular rice season to analyze the details of their farm. And then the data they got allowed them to optimize their water flow in the rice field. And by their estimation, they were able to reduce their water usage by 25%, resulting in efficient water management, right? So now they don't need to waste water. They had a proper structure because of the information, right, they got. Now, in addition to the use of drones, they're able to use that LiDAR data, right, to identify areas prone to diseases and nutrient deficiencies. And that allows the farmers to take appropriate measures to increase their yield by 12% per hectare. I mean, these are real life examples. Like if you go check it out, right? Real life examples. Because of the data they got using drones, they're able to increase their yield, their products, their yield production by 12%. That's a massive increase. And that was per hectares, right? So using the drone data, it allowed them to, because of that data now, they could look at, okay, this is how our fertilization process is going to be, right? So fertilizers, they're able to manage their fertilizers very well. They're able to manage their pesticides also very well. And they were able to reduce their chemical usage. Because of the data they got, apart from water management, apart from 12% increase in yield, they also reduced their usage of chemicals by 15%. And this contributed to environmental sustainability. Okay. I believe with this now you can see a lot of advantages of doing that. So now no more unnecessary use of pesticides and the likes on your plants. fertilizers can properly manage them. And if you're properly managing your fertilizers and your pesticides, also means it's saving you a lot of money, right? So they're able to save money while also increasing their yield and while also reducing the economic impact or the environmental impact because of the effect of chemicals, right, on the land. And then they're also able to increase their yield. Another example is the one for a maize farm in Kenya, right? Precision maize farming in Kenya. So in this instance, the maize farmers in the Rift Valley of Kenya, they implemented the use of drones equipped with multispectral sensors. And then one of the major sensors used in agriculture is now this is the multispectral sensors. And the project was initiated in 2019, and it has been ongoing since then. The objective of the project was to increase the yield and conserve resources. So the drones collected multispectral data to assess the soil health and the nutrient level across their maize fields. The soil map generated from this drone imagery helped farmers to identify the areas with nutrient deficiencies and optimize fertilizer application. By the analysis, they were able to have a 20% reduction in usage of fertilizers while maintaining an increase in maize yield. And that sounds counterintuitive. You know, you are using fertilizers majorly, right, to increase your yield. Because of your data, the usage of the fertilizers has reduced, but you are still maintaining an increased yield. And that's because you're able to apply them strategically or in the right places, right? So the multispectral images added by the drones enabled early detection of pests and diseases affecting the maize crops. And that allows them to promptly, right, initiate a pest control procedure. And that reduced their crop loss also by 15%. One other thing they noted was that in their, based on data they got also, it helped with their irrigation system. And they were able to reduce their water consumption by 30%. Their water usage decreased by 30%. And that helps in the water conservation efforts in that region. So as you can see, we are having a lot of increase in yield, increase in water conservation, decrease in pollution due to pesticides and all those kind of things, right? Which is more beneficial. Another one is targeted weed management in USA, right? So in the US, a group of soybean farmers in the Midwest region of USA implemented a project aimed at enhancing weed control efficiency. So the drones were actually equipped with RGB cameras this time around, and then they don't add a machine learning algorithm that was used to detect and map weed infestation across the field. So this drone had an RGB camera, but it had a machine learning system where as it's capturing those data, it's able to figure out and pinpoint the places where we had weeds, right? Now, once they had detected those weeds, what they did was they now took a crop sprayer, a drone sprayer, a precision drone sprayer, and the way they set it up is such that when it goes to fly, it targets those points where we had those weeds, properly targets them, and then it sprays the exact amount of quantity it needs to spray at those points. And the places that don't necessarily need those, the weed sprayer, the weed control, the chemicals, it does not put it there, right? So it just goes, pour it here. Oh, this point, as it's going, drop here, comes, drop here, oh, drop here, okay, drop here, oh, don't drop here, like that. That doing that actually also increased or decreased their usage of fertilizers, of the weed control mechanism, and it increased their yield, right? So their herbicide application reduced, they had more yield and more management, right? So that's one thing. In Nigeria as well, we have IAP, Integrated Area Precision, which is making use of agriculture across board, right, to target and deal with all manners of issues in the agricultural space in the country. All right, so this brings us to the next one, which is challenges and future directions, right? Challenges and future directions. So while the potential of drone technology in agriculture is vast, right? While it is vast, while you have a lot of opportunities, there are challenges to overcome. And some of these major challenges includes number one, cost. Number two is data management. And then number three is regulation constraints. Cost, data management, and regulation constraints. Right? So small scale farmers who are interested in using drone technology oftentimes face challenge due to the high costs or high initial cost, let me say, of getting the drone. And that's due to limited financing options, right? However, the cost of drones has decreased significantly over the past decades, right? For example, the average price of agricultural drones has dropped by approximately 40%, according to a research done by ID Tech in 2021, right? So another thing people do to curb this challenge is the fact that they form cooperatives, right? So you have a certain number of small scale farmers coming together, to address these pain points. So everybody comes together, they put in the money each of them they can afford, right? They distribute the cost among themselves to make it more feasible. Another thing is data management and analysis. All right, so data management and analysis presents a significant challenge due to the large volumes of data generated by these drones. Many of these data that are collected by drones are actually high quality data, which means they have big, large sizes. Apart from that, also they require specialization and sophisticated softwares, right, to analyze and get the information you need. Now, that's the interesting part. The future of drone technology is promising, especially with new innovations and advancements. Like for example, we have emerging technologies like artificial intelligence, like what we're talking about, machine learning and the likes. And this actually allows the analyzing of this data to be more easy and more straightforward, right? So we now have something that can automatically analyze data that you capture, thereby reducing the need for too much specialized knowledge in that case. One example is the technology by sea and spray precision. All right, so I'm very sure in the agricultural space we all know about John Deere. Or if you don't know, at least it's one of the major agricultural companies in the world. So they have this subsidiary which they got, which is the Blue River technology. And this Blue River technology, basically, they use computer vision and AI algorithm to identify and target individual weeds, reducing herbicide use by up to 90% compared to traditional broadcast spraying methods. Traditionally, if you want to do away with weeds, you basically have to spray, if not the entire farm, right? Basically, you have to spray the entire farm. But because of technologies like this, advancements like this, you can precisely, right, identify and target those individual weeds. At the moment, this is also being used for tractors and any other things, but it's also being implemented in the drone space. And then we also have the regulation constraints, right? Basically, in most cases, you need to have a license, and all those other things that you need to do to put in place, insurance for your drones and all those kind of things. At the moment, it's kind of difficult for some people, but then there are a lot of initiatives out there now that are making it easy, right, for farmers to come together and get all these things sorted. And that brings us to the end of this presentation, right? So drones have the potential to transform modern agriculture by optimizing resources utilization, increasing productivity, and by minimizing environmental impacts, right? The transformational impact is evident, right, by the increased adoption rates and the tangible benefits that are experienced and reported by farmers across the globe. Summarize, drones have immense potential in addressing global security challenges. For advancing drone technology and overcoming barriers to adoption in agriculture, continued research, investments, and collaboration are essential. Farmers like John Dilaga from South Africa has already experienced a 20% increase, right, in crop yield by implementing drone technology for precise agriculture into his farm. If you are a farmer, an agricultural enthusiast, or a professional, you could be next. All you have to do is embrace innovation and leverage on profitable agricultural practices like the use of drones to meet the growing demand of the rapidly changing world. That's the end of my presentation. Thanks for listening. So I'm opening the floor now for questions and answers, if there are. So if you have any questions, answers, something needs clarifications on, let me know. So let me stop sharing at this point.
Thank you so much, Mr. Hello, can you hear me, Mr. David?
Yes, I can. Go ahead.
Okay. Thank you very much. This, not gainsaying, this is a very profound and insightful presentation that you've took us through, and I am so much amazed at the wealth of your experience on drone technology. It's such inspiring and amazing. Uh, Although we have a lot of
Pleasure.
questions here, so I'm going to select some of them that we really need to put a touch to. So, okay.
All right. Yeah.
And I think we have compliments too for you. So,
Uh,
okay. It's another day. Good impact. No, no, no. Okay. Just some few questions. Okay. Okay. People actually asking, I wish I was in the class to fly. Yes, there are few questions. Okay. Let me check. So much information. Okay. Mm, okay. What we have here, they are not questions per se. So people are just giving their, are like having their own thoughts share. So around what you are doing. So it's not like so. I think we have
yeah, you
one
could, you could,
compliment
you
for
could go
you
ahead
from
and share
Miss
them.
Violet Osing. Okay, so she said his presentation skills and content are on another level. I am enjoying it. Yeah. So thank you.
You're welcome.
Someone was asking about this. Please help us zoom your lecture slide for good viewing. I think that is done. We don't
I
really
think we
have
addressed that.
much
Yeah.
question here, so to say.
Okay.
Someone was saying this. Please, what is the practical? Okay, I think this is one of the questions we can attend to. So, please, what is it practically doing during image
Doing
processing? Okay, so I think someone is asking this question in relation to drone data collection. So, when you're doing image processing, like what probably
okay.
is just need a clarification around the processing or what's it doing. So,
All right, all right. No issues. So basically, when you are carrying out image processing, like I said, the very first thing you need to do is to capture your data, right? So basically, you have your drone out there. So let's say you have a farm, and then you mark the area of that farm, and then your drone flies all over the farm. Now, while it is doing that, it's capturing images of that farm intermittently. Now, all these images are individual images, right? So singular images. So when it comes to your image processing, what happens is that it gathers in your image processing, you stitch those images together. Just like what you have on Google Map, for example. What you have on Google Map, example, are images captured by us by the satellite, right? But then on Google Map, they are merged together to become just one map. So all those images that you captured on your farm, once you take them into the image processing software, it first merges them together, right? So when it merges them together now, you now have a few view or a few picture, a complete picture of your farm. Now, once you have that, you can have different kind of things. So, for example, you can have the auto mosaic, which is a 2D model of the farm. If you're using LiDAR sensor, for example, basically have a 3D model of that farm. It is telling you about the height of your crop, the structure of the ground, and many other things. Now, once you gather that data, if you're a farmer, what you're majorly interested in, right, is okay, let's say, for example, is analyzing your crop health, right? So these softwares have features that allows you to generate this kind of data. Some of these data are called vegetation indices, right? Vegetation indices. So we have different kinds. We have NDVI, we have Barry, among others. Now, these indices gives you an overview of the situation of your farm, of your crop health. Um, Let me share my screen. Just give me a moment. Let me share my screen. Let me share something so you understand. Okay, just hold on, please. Open.
All right, no problem. So you can go ahead.
Okay, sharing my screen now. Can you see my screen? I'm sharing another screen now. Can you see that?
No, 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 no. It's
Okay,
not
stand
visible
by.
yet.
Okay.
Okay. Need to come on. The screen is not visible yet. Okay.
Yeah, just stand by. All right, so this is one. Can you see it now?
Okay. Yes, 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 yes. You can see.
All right, so this is an example of now basically what the drone captured was basically a regular image, more like what your eyes can see, right? Just a picture of the farmland. But now with the aid of a software, you're able to get something like this. What we have here on the screen now is NDVI, it's like a vegetation index. And then on this NDVI now, you can see different colors, right? So you have the green, you have the yellow, you have the orange, and you have the kind of red, right? Now each of these things
Yes.
means something to a data analyst, an agricultural data analyst. So from this, they can be able to tell, okay, which part of your farm, for example, needs more water, which part of your farm is affected by pests, depending on the vegetation indices, right? Depending on the vegetation data that you are getting. And with that, the farmer is able to make the precise decision he needs to make. So with this now, they can plan that, okay, for example, this is just a reference. For example, let's say you have a lot of grains on the screen. It means, okay, that, okay, your farmland is pretty good. So let's say in one area now, you have a lot of reds. Depending on the vegetation index, it could mean that, okay, there's crop infesting your plants, your farm, or maybe, oh, water is not getting enough to this area. So let's say you have an irrigation pipeline, but then water is not getting to this particular region. Okay, then you know that, okay, I need to create more pipes, or do that, to cover and do that issue. Right. So there are a lot of things, but that's what image processing really is. It's all about gathering image and then analyzing the image or the data to get and make useful decision.
Okay. Uh, that really makes sense. Thank you for that
Yeah. Well,
insightful answer. So, someone is giving a compliment here. So much information. Thank you. And
you're welcome, Samuel.
so we have other questions here. I think people are just popping in their
Yeah, go ahead.
questions. Yeah. So, Dick Pojukola is saying, "Wow, great lecture. Thank you." So, I think one other
Okay.
question we have here: how can other countries be able to learn from David and other experienced people in drone technology? I am from Rwanda. So, okay, it's just asking basically anyway.
Am I allowed to share that? All right. So
Mm,
basically,
okay, just give your thought around it. It's no problem.
um,
Uh,
learning is easy, right? So for example, this is a platform. Precision Field Academy is a platform, right, that allows you to pretty much learn. So I think with Precision Field Academy, right, you basically have the opportunity to, we could like connect and then talk depending on how things are. But another thing is I am on social media, right? So yeah, you can always follow me on social media if you need to, and then we can have a discussion. But I believe Precision Field Academy is the fact that you are here means you have a lot to learn.
okay. Thank you so much. Someone is giving Paul James representation. Okay, one question. So featuring drones and multi-rotor, which one is better for field layout? I think somebody is talking about maybe field mapping or doing field environment. So he was asking, probably wants to know the efficiency between the fixed wing and the multi-rotor, which one can work best.
All right. So basically on a general scale, right? So like I said, the first thing you need to consider is how large your farmland is when it comes to making these decisions. So fixed wings are known to fly longer ranges faster, right? So generally, fixed wings have like more coverage compared to multi-rotors, especially when it comes to mapping a field area. Right? If what you're doing now is to map an area, then multi-rotors is pretty much good for large farmlands. Nonetheless, if you have a small area, multi-rotors also suffice, right? So we have a lot of multi-rotors that are being used for, mapping farmlands and many other things. So, like I said, it depends on how large the farm is, type of multi-rotor you are getting, or the kind of fixed wing you are getting. So there's really no generic answer, but generally fixed wings are better for mapping. But then for operations like crop dusting and then
You have
stuff
a
like that that
question?
requires you hovering on the spots or doing things like that for a short period of time, then multi-rotors are a good bet.
Okay. Uh, Thank you very much, Mr. David. That's very, very profound. It's such a awesome time learning with you here. Thank you so much. Let me quickly check if we have other questions. I think there are no more questions available for now. So, in the absence of question, guys, I quickly need to make this announcement. So, since um, we've entered into the core week of drone technology, and most of the courses we are going to be discussing this week, 100% is centered on drone. So tomorrow we will be having another amazing section with Mr. Femi Adekoya, the flying farmer himself, and he will be taking us through drone technology and precision agriculture. So let's take note of this, although the announcement will be made and the necessary information will be shared on the group and the emails. Aside from this, this week on Thursday and Friday, we're going to be engaging on the virtual drone simulation training at our training facility here in Lagos, Ojodubaga precisely. So, and I've reached out to a lot of candidates here, so I'm still going to reach out to every other persons that also remains that we need to send this information to, so that Thursday and Friday is open for you to come around to engage in the virtual simulation training. Note that this is very, very essential for you going forward to or participate in the on-site drone practical training. So this virtual simulation, it's a very precise course which you don't want to miss because it can really affect you going forward. Okay, so aside from that, okay, so one other thing is that this week, if you remember last week, we shared some course link for everyone to participate on, which is under the independent learning. The course you can actually attempt online to learn at your own pace. So this week we are introducing you to a new course, RPAT certification. That's our remotely piloted aircraft technology certification from ADDA. So kindly note that the information will be shared on the group and also across the email platform, so for everyone to participate and have access to that. So, all right. I think in the absence of questions now, we don't have much question on ground anymore. Okay. I think a question just popped in from Paul Adekoju. He said, for one to be capable of operating a drone very well, there is room for continuous practice. Yes. Okay. Thanks so much for that. I think these are part of the key points that stood out for one of our participants, Paul James. He said, for one to be capable of operating the drone very well, there is room for continuous practice. Yes, exactly. So, we don't know how can. Okay, we also popped in another question here. How can one get access to drones for those who can't afford them but are into farming? Okay, Mr. David, I think we will have
All
one
right.
question to answer here.
Yeah, yeah. All right, good question, Mr. James. Like I already stated, right, for many farmers, the major issue, like you mentioned, is the fact that they cannot afford the drones. Or another thing is they don't have the skill set necessary to operate the drones. And that's why we have different companies, for example, integrated area precision. I don't know which country you are in, that offers those kind of services. So you don't necessarily have to buy the drone yourself for you to make use of them. We have drone companies that offer those stuff or those skill sets as a service. So, for example, if you needed to dust or spray your farm due to pesticide infestations, you can, reach out to this company, and then they give you an affordable package, right, to do that or to get that done. And that thing you could do is look out and see if you have like cooperatives or NGOs that are tailored to precision agriculture, and they could always connect you to, you know, all these organizations at a subsidized rate. I believe that answers the question.
Yes, 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 yes. That answers the question. Thank you very much for that. So I don't think we have other questions available. Yes, so no questions for now. Guys, I would say we've come to the end of this presentation. Mr. David really did an amazing job. He did a justice to this presentation. Personally, I also learned a lot of things from this section. Thank you so much, Mr. David, for that. And I believe our participants
Always a pleasure.
gained one or two insight from you, sir. So it's really a great opportunity to learn from here. So, guys, will communicate to you via the information group, the WhatsApp platform, and also via your email, so you can get the necessary information you need. Thank you very much. Bye, everyone.